Assalamualaikum and good day. My name is Nohannah binti Tajuddin. Along with my teammates Nur Alia Izzati and Ni'iman Zahira, will be presenting one of the MAT183 topic, which is related rates. Understanding related rates is crucial for problem solving and gaining insights into dynamic systems. It provides a mathematical framework for modeling and analyzing situations where multiple variables are changing simultaneously. As such, related rates are an essential part of a calculus curriculum and are widely used in various scientific and engineering disciplines. The process of solving related rates problems typically involves using the chain rule of differentiation and implicit differentiation. Here's a general outline of the steps involved in solving related rates problems. Firstly, you need to identify variables. Clearly define the variables involved and their relationships. Secondly is to write an equation. Formulate an equation that represents the relationship between the variables. Thirdly, differentiate implicitly. Take the derivative of both sides of the equation with respect to time. Fourth, plug in known values. Substitute the given values and known rates into the derivative expression. Fifth, solve for the unknown rate. Isolate the unknown rate in the equation and solve for it. Lastly, interpret the result. Once you find the unknown rate, interpret the result in the context of the problem. What is related rates? Problems that involve two or more quantities and their corresponding rates of change with respect to time. The relationship between these two quantities is used to express their related rates in terms of the other quantities known as the rate of change. It helps to determine how fast or slow a certain quantity is changing using the rate of change of the second quantity. Sand pouring from a chute forms a conical pile whose height is 3/4 times the radius. If the volume increases at a rate of 4 meter cube per second, how fast is the radius changing when the radius is 4 meter? From the statement, we know the height, radius, and rate of volume increases. What we need to find is rate of radius changing.
How to solve this question? From the information, dV/dt is already given, and we need to find the RDT. To get the RDT, we need to get rid of dV by using a new equation, which is the RDT equals dV/dt times dV/dr. To get dV/dr, we need to find the value for volume of cone. Using the formula, V equals 1/3 pi r square h. From the information, we can substitute h equals to 3/4 r. Solve the substitution, then we get this as the volume of the cone. Next, we need to differentiate the volume because V is already in terms of R. Therefore, we will get dV/dr from the volume, which is 3 pi r square over 4. For the last step, we need to form a new equation using cross multiplication by changing dV/dr to dr dV. The equation is dr over dt equals dV over dt times dr over dV. We already have the information for dV over dt and dr over dV, so we can substitute dV over dt as 4 and dr over dV as 4/3 pi r square. And we can substitute r equals to 4, and the final answer will be 1/3 pi meter per second.
There is also another alternative way to solve this problem. First thing first, we also need to find value for volume of cone, then differentiate it to find dV over dr. Instead of using cross multiplication method like we did just now, we can form a new equation which is dV over dt equals to dV over dr times dr over dt. So from here, we can substitute dV over dt equals to 4 and dv over dr equals to 3 pi r squared over 4. And from the information given, we can substitute r equals to 4. And from here, we will get the last answer, which is dr over dt equals to 1 over 3 pi meter per second. So, for the conclusion, the rate of change in radius of descent when the volume increases at a rate of 4 meter cube per second is 1 over 3 pi meter per second. We can use volume of cone formula when solving any problem that involves finding rate of changes related to the circular cone. And that's all from us. Thank you.